Today we're continuing our study on ionic compounds, but instead of looking at how the metals and the nonmetals bond together through the transfer of their electrons, we are going to be talking about how we discuss ionic compounds and name them correctly so that we don't have to rattle off their chemical formulas, which can be kind of lengthy sometimes. So we have an agreed upon set of rules for naming, and sometimes naming is called nomenclature. So as we've talked about before, whenever we have an ionic compound, it has a cation and it has an anion in the chemical formula. So whenever you are writing a chemical formula, you start with the cation. The same is true for naming it. So you will always want to start with the cation. And similarly, if we're starting with the cation, then you will be writing the anion after the cation. That will always be the pattern. Start with the cation, finish with the anion. When naming the cation, or the first part of your chemical formula, there are a few different options for what type of cation you're working with. So the first option is to have a regular cation. And a regular cation is going to be any element in kind of those A groups that are metals. So that would be the alkali earth metals, the alkali metals, and the aluminum group, kind of 1A, 2A, 3A. And those you just write their element names, and you have named the cation appropriately. So if it's a regular element, regular metal, write the element name. So for example, if in my formula I have K as the cation, I would look it up on my periodic table and write the element name, which is potassium. And then I'm done naming the cation. The other option we have is that we have a polyatomic cation. And in this case, you are going to simply write the listed name of that particular polyatomic ion. So the cation that is also polyatomic, there's only one. It is ammonium. It's one of the ones we've been working on memorizing. And remember that anytime you see a cation or an anion, any ion in a chemical formula, it will not have the charge. So if you were to find ammonium in a chemical formula, it could look like this, or it might have parentheses around it, like this. So the cation portion does not have a charge in it. Neither of the portions will have charge. First part is the cation, and you would name this as ammonium. And then you would name the second part here according to the anion rules, which we will get to in a moment. The third type of cation that you could have is a transition metal, and the transition metals, remember, are in the D block, and those metals have what's called a varying oxidation state, and the oxidation state is what gives them their charge. And so they can exist with a few different possible charges depending on the element that they are representing, or the ion that they are representing in the compound, giving off, 2, 3, 4, 5 electrons, causing them to have different charges. So what we'll have to do for transition metal is show the charge with a Roman numeral. You'll start with the same process, write the element name, and then you'll follow it with a Roman numeral. And the Roman numeral represents the charge. So on the bottom of our box here, you'll see 1 through 10 in Roman numerals. If your element has a 1, this is capital I, it's a positive 1 charge. II is a positive 2. III, positive 3. IV, positive 4. V by itself is positive 5. VI is positive 6. Generally, that's all we will be working with, but for the sake of Roman numerals and learning what they are, VII is 7, VIII is 8, Ix is 9, and X by itself is 10. There are the Roman numerals for 1 through 10 and what they represent in our cation. It's the charge. They are always positive because they are cations. Remember, cations are always positive. So that's naming our cation portion of the ionic compound. Let's move on to the anion portion. We said we always write the anion after the cation. And on the anion, we only have 2 options of kind of the type of ion we are working with. There's regular or there's polyatomic. There are no special groups like the transition metals for our nonmetals. So if it's a regular nonmetal, that means it is on the periodic table, any nonmetal that is present. And if you are naming that anion, what you will do is write the element name, but you will slightly modify it with a different ending. Write the element name with modified ending. And that ending, or suffix, we will change to IDE. So a couple of examples, if you had chlorine, you would change that ending of I and E to IDE, and now it's chloride. Or another one, maybe you had nitrogen, you'll take that suffix and change it to IDE, nitride. Another one, sulfur. Change the ending, sulfide. One other that's kind of strange is phosphorus. Phosphorus. You will, oops, I totally spelled that wrong. There we go. So you are going to take our urous ending and change it to IDE. So you'll have phosphide. Okay, so always change that suffix to IDE and you have named your anion. If you have a polyatomic ion, again, just like with the cation, write the listed name. If you turn to page 4, you will see a list of common polyatomic ions, including the ones that we're learning and memorizing. And they are all written here. So all of our anions, hydroxide, nitrate, sulfate, carbonate, phosphate, if you see them in a chemical formula, then you'll write that listed name. And then there are other ones that we're not memorizing, but also are common. Acetate, oxalate, cyanide, nitrite. Just read the listed name and write it down. You'll notice that almost all of these have an ite or ate ending, with the exception of cyanide and hydroxide. All of the rest of the anions have an ate or an ite ending. Okay, so let's go ahead and apply these rules to some examples, going first from the compound to the name, and then we'll go from the name to the compound. So whenever we're working with ionic compounds, we have set up here a little box set. We'll break it apart into the cation and the anion, and then we'll name each separately using the correct rules. So in this compound, we have barium and we have chlorine. Those are our 2 elements. And if you kind of remember that crisscross method, you can sort of reverse crisscross to get the ions back. And we have barium, positive 2 charge here, and chloride. Okay. And another way to check their charges if you're having a hard time kind of seeing the reverse crisscross is just look back at your periodic table. Barium is in the alkaline earth metal, so it always has a +2 charge. That goes back to following the octet rule and giving away 2 valence electrons. And chlorine, similarly, will always make a -1 charge because it has 7 valence electrons and gains 1. So if you're ever unsure about charge, just go back to your periodic table and use the trend. Now let's name these. First, cation. This is a regular cation, so we're just going to write its name, barium. No Roman numeral needed because it's not a transition metal. And then our anion is chlorine. This is one of the examples we did in the notes, so this would be chloride for the anion. barium chloride. Easy as that. Let's do one where we have a transition metal. Gap. Actually, I don't even think that is a transition metal. We don't have any on this one. Those are saved for Wednesday, I forgot. So Wednesday we'll really focus in on transition metals. So you should be able to do all the rest of the compound to name using listed names of polyatomic ions or element names. Let's do one more for the sake of looking at a polyatomic ion. So we've got Al, +3 charge, and NO3, which we are memorizing has a -1 charge. Or you can use the list to find it. And now we name them. So Al is a regular element. This is aluminum. And then NO3 is nitrate. So this guy's name is aluminum nitrate. Okay, now going the other way, starting with the name and working back to the formula, we will still write the ions, and then we'll do that crisscross method to write the compound formula. So magnesium, start by writing the element symbols for each of these. In oxide, that's oxygen on the periodic table. And then use it to find that charge trend. If you forgot, group 1 is +1, group 2 is +2, group 13 is +3, and then group 14 does not have charge. Then we work our way back down. Group 15 is -3, group 16 -2, 17 -1, and noble gases do not have a charge. So using that trend, magnesium is a +2, oxygen is -2. So we do the crisscross method and you get Mg2O2, but remember we need to reduce. This will just be MgO, kind of a 1-to-1 ratio there. If you think back to the puzzle pieces, you would have had one of each in your chemical formula. MgO. Alright, so let's do a couple more on this. Ammonium nitride. Again, use your periodic table or the polyatomic ion list. Ammonium is on the polyatomic ions. NH4 +1. And nitride, this is different than nitrate that we saw up here. Nitrate is the polyatomic ion. Nitride is just nitrogen. So use those rules in the reverse to help you know which one you're working with. And then use the trend for charge. Nitrogen makes a -3 charge. And then the crisscross method. NH4, then we'll need parentheses to have 3 of them. And then ammonium nitride. And let's go ahead to the end of the row here and do a transition metal, tin to phosphate. Tin, find that on your periodic table, is Sn. The 2 is telling us we have a +2 charge because you do not have a trend to follow for the charge there. And then phosphate is polyatomic ion list, PO4, -3. Use the crisscross method to write the formula. And we're done. Ta-da!